Question number 21. We've got some tiles. Tiles are taken and the number is recorded. This is a key point here in the first part of the question. He does not replace the tile after selecting it. Calculate the probability that both tiles Jim takes has the number 1 in them. There are 7 tiles altogether. 2 of them have a number 1, so the probability that the first tile has a number 1 is 2 out of 7. After he's chosen a tile, which is a number 1, he now has 6 tiles left. One of those has a number 1 on it. So the probability that the second one he chooses also has a number 1 is now 1 out of 6. And the probability that the first one and the second one both have a 1 on is found by multiplying those two fractions together, which is 2 over 42. Part B. What's the probability that the number on the second tile is greater than the number on the first tile? Really useful to see all of the possible outcomes in this question, and the most efficient way to do that is to do a sample space diagram where we record all the possible numbers that could be taken on the first pick, and then all the possible numbers for the second pick. We can get rid of some of the spaces in the sample diagram. If you pick the one here, you can't pick it again the second time. If you pick the second one, you can't pick it on the second. So we can remove all of these down here because they're impossible. Now, all of these squares, all of these spaces in the sample space diagram represent a different outcome. This one, for example, is picking a 1 on the first time and then picking one of the 2's the second time. And that does satisfy the condition, the number on the second tile being greater than the number on the first tile. So that one is one possible outcome. If you go through the table and identify all of the other possible outcomes where the second tile picked is greater than the first tile, you can see that altogether there are 16 of them. There are 42 possible outcomes altogether. So therefore, the probability is 16 over 42.